Hello everyone. Today we will discuss the difference between semiconductors, conductors and insulators on the basis of the energy bands. So before we start today's topic, we need to recall what are energy bands and how these were formed, though we have discussed it in a separate video, right? So when the atoms come closer to form a crystal, then no two electrons have same energies. Why? Because each of the electrons sees different surroundings due to different atoms at different positions with respect to it. So what happens is that if we have this atom, this atom, this atom, many atoms coming closer to form a crystal, so every atom is having nucleus and shells. So there is an interaction between the shells, and due to this interaction each electron will have different surrounding. Each electron will have different surrounding due to different atoms. So that's why the energy levels of these atoms spread to form closely spaced energy levels, which is called as energy bands. So the first thing is energy band is formed when the crystals are formed from atoms. Right? And what is this energy band? It is a group of closely spaced energy levels. Detailed discussion we have already done in the previous video. Now, how many types of energy bands we have discussed? We have discussed the valence band. So you can say valence band is formed of for the energy levels in which valence electrons are there. Has valence electrons. It may be completely filled or partially filled. Then we have conduction band. This band of closely spaced energy levels has conduction electrons or free electrons. So at this conduction band may be completely empty or partially filled. Sorry. This completely. Then there is an energy gap between the two, or you can say there may be the energy gap between the two in case of conductors. or there may be overlapping in case of conductors, but in semiconductors and insulators then there is an energy gap. So there is another term which I am just defining here, energy gap. Is the energy difference between the lowest energy of conduction band that is denoted by EC and the highest energy of valence band, that may be denoted by this. Okay, so this is all about energy bands. Now we are going to discuss the difference between conductors, semiconductors and insulators on the basis of the band theory. So I am writing the headings over here. So conductors are the materials which conduct, we know that. So here in this case what happens is that the difference between the valence band and the conduction band is nearly zero, or there may be overlapping of the valence band and the conduction band. So I'll draw both the diagrams. One is this, or so valence band, and this one is showing the this is the conduction band, this is the valence band. In this case there is overlapping, right? And here in this case this energy gap is nearly 0. So there may be overlapping or nearly zero energy gap. So this arrow is showing the increasing electron energies, or you can say increasing energy. Right? So in this case, what happens is that the conduction band here may be partially filled and valence band right, or valence band is partially empty. So if conduction band is partially filled, so it may conduct due to the presence of electrons in the conduction band, and if valence band is partially empty, the electrons may jump from the lower to the higher energy state, right? So that way conduction is possible. And in this case, since there is no energy difference between valence band and conduction band, the electrons may easily move to the conduction band, and that's why they can conduct, right? So the important thing over here is the conductors conduct, right? And here the energy gap is nearly zero, or valence band and conduction band overlap, right? So I'll write the full form of the conduction band and valence band, where CB is conduction band and VB is valence band. Now we will draw the diagram for the semiconductors. In case of semiconductors, the energy gap between the conduction band and the valence band is less than 3 electron volt. And this is the energy gap. Then we have, one thing is very important over here. At 0 Kelvin, the conduction band is completely empty as all the electrons are covalently bonded in the valence shell with the other 4 atoms which are surrounding it to complete the octet. So at 0 Kelvin, the conduction band is completely empty, right? So no conduction possible. Therefore, you can say that the semiconductors behave as insulators at 0 Kelvin. So the semiconductors behave as right, but as the temperature rises, or you can say even at the room temperature, at room temperature some electrons in valence band may get sufficient energy to reach the conduction band to overcome this energy gap, right? So at that time, even at room temperature, the semiconductors can conduct because they gain enough energy due to the heat, or you can say due to the temperature. So that's why you can say that above, as the temperature rises, some electrons in valence band may gain sufficient energy to cross energy gap and reach conduction band to conduct. Right? So in this case, conduction is possible even at room temperature. So valence band closely spaced energy levels I am showing here. Similarly, conduction band may closely spaced energy levels I am showing here. I am not showing any electrons, just a symbolic representation of the energy levels. Now in case of insulators, the energy gap between the valence band and the conduction band is very large. That means you can say it is greater than 3 electron volt. So that's why the insulators cannot conduct, because it is not possible for the electrons to gain this much energy to cross the energy gap and reach the conduction band. So here we can draw the diagram like this, where the energy gap is greater than 3 electron volt. This energy gap is between the conduction band and the valence band. So again, I can show the closely spaced energy levels of valence band with red line. Now here the conduction band is completely empty. right? Why? Because the energy gap is very, very large. So electrons from valence band cannot cross this energy gap, right? So this is increasing energy towards the conduction band. Now I can show the closely spaced energy levels in conduction band by a different line, so that the overlapping in case of conductors is clear. So this is suppose the closely spaced energy levels of conduction band. This overlapping is clear here. Here I have shown these separately, no issues. Now with temperature rise, there is no change in the conductivity of the insulators because the energy gap is very, very large. So this was the difference between conductors, insulators and semiconductors on the basis of the band theory. So that's all for now. Have a nice day.